As times and seasons evolve in the world of military aviation, a new era is on the brink of arrival. A fighter jet of unprecedented design, capable of reshaping air dominance, stands for a new beginning. Alongside it, a fleet of stealth drones, each a marvel of technology and strategy, prepares to transform the future of combat. With advanced engines, cutting-edge weapons, and sophisticated artificial intelligence, these innovations promise to alter the balance of power. But with rival nations advancing their own high-tech, the stakes are higher than ever. Will these breakthroughs secure the skies or ignite a new arms race? How will these technological leaps influence the landscape of modern warfare? Let's discover how the U.S. Air Force is ready to shock China with its new fighter jets. New technology. The United States Air Force is once again showcasing its top-notch fighter jets, leaving rivals amazed. Launched in 2014, the Next Generation Air Dominance program represents a major leap forward for the United States Air Force. It's not just about a single jet, but a whole range of systems. This includes the development of a new fighter, the FX, or penetrating counter-air, and supporting technologies. A key part of this is the collaborative combat aircraft, also known as the Loyal Wingman. These advanced drones are designed to work with manned jets, enhancing their abilities and providing critical support during combat. The Next Generation Air Dominance program isn't just about jets. It also involves creating cutting-edge weapons, such as hypersonic missiles, advanced sensors, and improved avionics. Another important aspect is developing new adaptive engines, which are expected to improve performance and efficiency. The first flight-ready versions of these engines might be ready by 2025, with the FX fighter itself expected to be operational around 2030 to 2031. This puts the Next Generation Air Dominance program at the forefront of global fighter jet development, giving the United States a potential edge over its competitors. The Next Generation Air Dominance. The Next Generation Air Dominance program takes a comprehensive approach to air dominance. It's about more than just building faster or stealthier planes. It's about creating a complete ecosystem of advanced technologies that work together. This includes networking capabilities for better communication and coordination between various air platforms, making the fighting force more integrated and effective. The Collaborative Combat Aircraft, or Loyal Wingman, is a groundbreaking concept in military aviation. These advanced drones are designed to work alongside manned jets, expanding their capabilities and providing essential support in combat. Unlike simple drones, collaborative combat aircraft are sophisticated machines that can operate semi-autonomously. They can be controlled by pilots in nearby manned jets or potentially by ground operators, adding a new dimension to air combat. One major advantage of collaborative combat aircraft is their ability to undertake high-risk missions without endangering human pilots. They can be used for reconnaissance, act as decoys, or carry extra weapons to boost the power of manned jets. With collaborative combat aircraft, a single piloted jet could control multiple drones, greatly enhancing its combat effectiveness. This allows for more flexible and adaptable combat formations that can handle various threats and scenarios. Collaborative combat aircraft will also come with advanced sensors and communication systems to gather and share vital battlefield information. This improves situational awareness for pilots and commanders, leading to better decision-making in complex combat situations. Additionally, collaborative combat aircraft can be quickly updated with new software, sensors, or weapons, ensuring they stay at the cutting edge of technology throughout their service. The development of collaborative combat aircraft also presents challenges in human-machine interaction and artificial intelligence. Pilots will need new training and tactics to effectively manage these unmanned wingmen. Although the specifics of collaborative combat aircraft are still classified, they are expected to use stealth technology to avoid detection, making them ideal for penetrating heavily defended airspace. Other countries, like Australia and the United Kingdom, are also developing similar systems, showing a global trend towards this new type of air warfare. Overall, the Next Generation Air Dominance program is pushing the limits of aviation technology, setting the stage for a new era in air dominance. But which of these jets really stands out? And can China catch up with the United States Air Force anytime soon? Technological features for the NGAD. China is pursuing similar stealth and aerodynamic concepts as those being developed for the Next Generation Air Dominance program. As these next-generation fighters take shape, the United States Air Force is preparing to bid farewell to one of its most iconic aircraft, the F-22 Raptor. Plans are in place to retire the F-22 fleet by 2031, which will coincide with the expected introduction of the next-generation air dominance fighters. Its retirement will mark the end of an era in military aviation and highlight the rapid pace of technological advancement in fighter aircraft design. The F-35 Lightning II has emerged as a versatile and highly sought-after fighter jet, quickly becoming a cornerstone of modern air forces worldwide. Unlike its predecessor, the F-22 Raptor, the F-35 was designed with multiple roles in mind, capable of both air superiority missions and ground attack operations. One of the F-35's key strengths is its adaptability across different branches of the military. The aircraft comes in 3 variants: the F-35A for conventional takeoff and landing, the F-35B for short takeoff and vertical landing, and the F-35C for carrier operations. This flexibility allows it to serve the needs of the Air Force, Marine Corps, and Navy, streamlining logistics and maintenance across services. The fighter's popularity extends beyond United States borders, with many allied nations participating in the Joint Strike Fighter program. This international collaboration has made the F-35 a common platform among NATO members and other United States allies, fostering interoperability and shared tactical advantages. A significant aspect of the F-35's design is its advanced sensor fusion and networking capabilities. The aircraft acts as a flying sensor node, collecting and distributing vast amounts of data to other platforms, enhancing overall battlefield awareness. This feature transforms the F-35 from a mere fighter jet into a key component of a larger interconnected combat system. Despite facing challenges during its development, including software issues and cost overruns, the F-35 program has persevered. In 2022, Lockheed Martin announced the assembly of the 1,000th F-35, highlighting the aircraft's production success and growing global fleet. The F-35's combination of stealth, advanced avionics, and multi-role capabilities positions it as a critical asset for air forces well into the future, with plans for its operation extending potentially to 2070. The F-35 Lightning II's design is a masterclass in modern stealth technology. Its shape and materials are carefully engineered to minimize its radar cross-section, making it extremely difficult for enemy radar systems to detect the aircraft. Stealth features include carefully leveled edges and serrated skin panels that help scatter radar waves, reducing the jet's visibility. The engine and turbine surfaces are also masked to prevent them from creating easily detectable radar signatures. Learning from the F-22 Raptor's experience, the F-35's designers made significant improvements in the aircraft's stealth coating. The Lightning II's absorbent fiber matte skin is more durable and requires less maintenance than its predecessor, addressing a key concern in stealth aircraft operation. To maintain its stealthy profile, the F-35 is equipped with 2 internal weapons bays. These compartments allow the aircraft to carry munitions without compromising its radar-evading shape. Each bay can accommodate 4 combat modules, housing a variety of weapons, including air-to-air missiles and precision-guided bombs. The F-35's stealth capabilities are integral to its overall combat strategy, allowing it to penetrate heavily defended airspace and engage targets before being detected. This ability to operate in contested environments is crucial for modern air warfare scenarios. Importantly, the F-35's design also considers maintenance efficiency. Approximately 95% of the parts that are replaced in the field are one deep, meaning they can be accessed and replaced without removing other components. This design philosophy significantly reduces maintenance time and complexity, enhancing the aircraft's operational readiness. The combination of advanced stealth features and practical design considerations makes the F-35 a formidable and efficient combat aircraft, capable of operating effectively in highly challenging environments. The F-35 Lightning II boasts an impressive and diverse weapons arsenal, making it a truly multi-role fighter. Its internal weapons bay can accommodate a wide range of munitions, allowing the aircraft to adapt to various mission types without compromising its stealth profile. The F-35's arsenal includes air-to-air missiles for dogfighting and intercepting enemy aircraft. For ground attack missions, it can carry Joint Direct Attack munitions, which are GPS-guided bombs known for their precision. The aircraft is also capable of deploying paveway laser-guided bombs and joint standoff weapons for striking targets from a distance. In addition to these conventional weapons, the F-35 can carry cluster munitions for area denial operations and precision strikes against armored targets. It is equipped with small-diameter bombs like the GBU-39 and GBU-53B SDB-2, and can also deploy anti-tank Spear 3 missiles, further enhancing its ground attack capabilities. This versatile weapon loadout allows the F-35 to switch between air superiority and ground attack roles seamlessly, often within the same mission. This flexibility is a key factor in the aircraft's growing popularity among air forces worldwide. The emphasis on efficient maintenance extends to the F-35's software systems as well. The aircraft's modular design allows for easier upgrades and updates to its complex avionics and mission systems, ensuring it can adapt to new threats and incorporate improved technologies throughout its service life. The F-22 Raptor, a legendary aircraft in the United States Air Force fleet, is preparing for its final chapter. How confident is the Air Force in its ability to withstand the test of time? Designs and strengths of the fighter jets. China is working on stealth and aerodynamic designs similar to those being developed for the next-generation air dominance program. As these next-generation fighters are developed, the United States Air Force is preparing to say goodbye to one of its most iconic aircraft, the F-22 Raptor. Plans are to retire the F-22 fleet by 2031, which will align with the expected introduction of the next-generation air dominance fighters. This retirement will mark the end of an era in military aviation and highlight the fast pace of technological advancements in fighter aircraft design. The F-35 Lightning II has become a versatile and highly sought-after fighter jet, quickly establishing itself as a cornerstone of modern air forces worldwide. Unlike its predecessor, the F-22 Raptor, the F-35 was designed for multiple roles, including air superiority and ground attack operations. One of the F-35's key strengths is its adaptability across different branches of the military. The aircraft comes in 3 variants: the F-35A for conventional takeoff and landing, the F-35B for short takeoff and vertical landing, and the F-35C for carrier operations. This flexibility allows it to meet the needs of the Air Force, Marine Corps, and Navy, streamlining logistics and maintenance across services. The F-35's popularity extends beyond United States borders, with many allied nations participating in the Joint Strike Fighter program. This international collaboration has made the F-35 a common platform among NATO members and other United States allies, fostering interoperability and shared tactical advantages. A significant aspect of the F-35's design is its advanced sensor fusion and networking capabilities. The aircraft acts as a flying sensor node, collecting and distributing vast amounts of data to other platforms, which enhances overall battlefield awareness. This feature transforms the F-35 from a mere fighter jet into a key component of a larger interconnected combat system. Despite facing challenges during its development, including software issues and cost overruns, the F-35 program has succeeded. In 2022, Lockheed Martin announced the assembly of the 1,000th F-35, highlighting the aircraft's production success and growing global fleet. The F-35's combination of stealth, advanced avionics, and multi-role capabilities positions it as a critical asset for air forces well into the future, with plans for its operation extending potentially to 2070. The F-35 Lightning II design represents a masterclass in modern stealth technology. Its shape and materials are carefully engineered to minimize its radar cross-section, making it very difficult for enemy radar systems to detect the aircraft. Stealth features include carefully leveled edges and serrated skin panels that help scatter radar waves, reducing the jet's visibility. The engine and turbine surfaces are also masked to prevent them from creating easily detectable radar signatures. Learning from the F-22 Raptor's experience, the F-35's designers made significant improvements in the aircraft's stealth coating. The Lightning II's absorbent fiber match skin is more durable and requires less maintenance than its predecessor, addressing a key concern in stealth aircraft operation. To maintain its stealth profile, the F-35 is equipped with 2 internal weapons bays. These compartments allow the aircraft to carry munitions without compromising its radar-evading shape. Each bay can accommodate 4 combat modules housing various weapons, including air-to-air missiles and precision-guided bombs. The F-35's stealth capabilities are integral to its combat strategy, allowing it to penetrate heavily defended airspace and engage targets before being detected. This ability to operate in contested environments is crucial for modern air warfare. Importantly, the F-35's design also considers maintenance efficiency. Approximately 95% of the parts that are replaced in the field are one deep, meaning they can be accessed and replaced without removing other components. This design philosophy significantly reduces maintenance time and complexity, enhancing the aircraft's operational readiness. The combination of advanced stealth features and practical design considerations makes the F-35 a formidable and efficient combat aircraft, capable of operating effectively in highly challenging environments. The F-35 Lightning II boasts an impressive and diverse weapons arsenal, making it a truly multi-role fighter. Its internal weapons bay can accommodate a wide range of munitions, allowing the aircraft to adapt to various mission types without compromising its stealth profile. The F-35's arsenal includes air-to-air missiles for dogfighting and intercepting enemy aircraft. For ground attack missions, it can carry joint direct attack munitions, which are GPS-guided bombs known for their precision. The aircraft is also capable of deploying paveway laser-guided bombs and joint standoff weapons for striking targets from a distance. In addition to these conventional weapons, the F-35 can carry cluster munitions for area denial operations and precision strikes against armored targets. It is equipped with small-diameter bombs like the GBU-39 and GBU-53B SDB-2 and can also deploy anti-tank Spear-3 missiles, further enhancing its ground attack capabilities. This versatile weapon loadout allows the F-35 to switch between air superiority and ground attack roles seamlessly, often within the same mission. This flexibility is a key factor in the aircraft's growing popularity among air forces worldwide. The emphasis on efficient maintenance extends to the F-35's software systems as well. The aircraft's modular design allows for easier upgrades and updates to its complex avionics and mission systems, ensuring it can adapt to new threats and incorporate improved technologies throughout its service life. The F-22 Raptor, a legendary aircraft in the United States Air Force fleet, is preparing for its final chapter. How confident is the Air Force in its ability to withstand the test of time? Designs and strengths of the fighter jets. China is working on stealth and aerodynamic designs similar to those being developed for the next-generation air dominance program. As these next-generation fighters are developed, the United States Air Force is preparing to say goodbye to one of its most iconic aircraft, the F-22 Raptor. Plans are to retire the F-22 fleet by 2031, which will align with the expected introduction of the next-generation air dominance fighters. This retirement will mark the end of an era in military aviation and highlight the fast pace of technological advancements in fighter aircraft design. The F-35 Lightning II has become a versatile and highly sought-after fighter jet, quickly establishing itself as a cornerstone of modern air forces worldwide. Unlike its predecessor, the F-22 Raptor, the F-35 was designed for multiple roles, including air superiority and ground attack operations. One of the F-35's key strengths is its adaptability across different branches of the military. The aircraft comes in 3 variants: the F-35A for conventional takeoff and landing, the F-35B for short takeoff and vertical landing, and the F-35C for carrier operations. This flexibility allows it to meet the needs of the Air Force, Marine Corps, and Navy, streamlining logistics and maintenance across services. The F-35's popularity extends beyond United States borders, with many allied nations participating in the Joint Strike Fighter program. This international collaboration has made the F-35 a common platform among NATO members and other United States allies, fostering interoperability and shared tactical advantages. A significant aspect of the F-35's design is its advanced sensor fusion and networking capabilities. The aircraft acts as a flying sensor node, collecting and distributing vast amounts of data to other platforms, which enhances overall battlefield awareness. This feature transforms the F-35 from a mere fighter jet into a key component of a larger interconnected combat system. Despite facing challenges during its development, including software issues and cost overruns, the F-35 program has succeeded. In 2022, Lockheed Martin announced the assembly of the 1,000th F-35, highlighting the aircraft's production success and growing global fleet. The F-35's combination of stealth, advanced avionics, and multi-role capabilities positions it as a critical asset for air forces well into the future, with plans for its operation extending potentially to 2070. The F-35 Lightning II design represents a masterclass in modern stealth technology. Its shape and materials are carefully engineered to minimize its radar cross-section, making it very difficult for enemy radar systems to detect the aircraft. Stealth features include carefully leveled edges and serrated skin panels that help scatter radar waves, reducing the jet's visibility. The engine and turbine surfaces are also masked to prevent them from creating easily detectable radar signatures. Learning from the F-22 Raptor's experience, the F-35's designers made significant improvements in the aircraft's stealth coating. The Lightning II's absorbent fiber matte skin is more durable and requires less maintenance than its predecessor, addressing a key concern in stealth aircraft operation. To maintain its stealth profile, the F-35 is equipped with 2 internal weapons bays. These compartments allow the aircraft to carry munitions without compromising its radar-evading shape. Each bay can accommodate 4 combat modules housing various weapons, including air-to-air missiles and precision-guided bombs. The F-35's stealth capabilities are integral to its combat strategy, allowing it to penetrate heavily defended airspace and engage targets before being detected. This ability to operate in contested environments is crucial for modern air warfare. How does its maintenance impact these stealth capabilities? High maintenance. The F-35's design also emphasizes maintenance efficiency. Approximately 95% of the parts replaced in the field are one deep, meaning they can be accessed and replaced without removing other components. This design significantly reduces maintenance time and complexity, enhancing the aircraft's operational readiness. The combination of advanced stealth features and practical design considerations makes the F-35 a formidable and efficient combat aircraft capable of operating effectively in highly challenging environments. The design philosophy of one deep means that components can be accessed and replaced without removing other parts. This approach significantly reduces maintenance time and complexity, enhancing the aircraft's operational readiness. The combination of advanced stealth features and practical design considerations makes the F-35 a formidable and efficient combat aircraft, capable of operating effectively in highly challenging environments. The F-35 Lightning II boasts an impressive and diverse weapons arsenal, making it a truly multi-role fighter. Its internal weapons bay can accommodate a wide range of munitions, allowing the aircraft to adapt to various mission types without compromising its stealth profile. The F-35's arsenal includes air-to-air missiles for dogfighting and intercepting enemy aircraft. For ground attack missions, it can carry joint direct attack munitions and air-to-surface weapons, which are GPS-guided bombs known for their precision. The aircraft is also capable of deploying paveway laser-guided bombs and joint standoff weapons for striking targets from a distance. In addition to these conventional weapons, the F-35 can carry cluster munitions for area denial operations. For precision strikes against armored targets, it is equipped with small-diameter bombs like the GBU-39 and GBU-53B small-diameter bomb 2. The fighter can also deploy anti-tank Spear-3 missiles, further enhancing its ground attack capabilities. This versatile weapon loadout allows the F-35 to switch between air superiority and ground attack roles seamlessly, often within the same mission. This flexibility is a key factor in the aircraft's growing popularity among air forces worldwide. The emphasis on efficient maintenance extends to the F-35's software systems as well. The aircraft's modular design allows for easier upgrades and updates to its complex avionics and mission systems, ensuring it can adapt to new threats and incorporate improved technologies throughout its service life. The F-22 Raptor, a legendary aircraft in the United States Air Force fleet, is preparing for its final chapter after serving as the benchmark for fifth-generation fighters worldwide. The Air Force plans to retire the F-22 by 2031, coinciding with the expected introduction of next-generation aircraft from the Next Generation Air Dominance program. Since its first flight in 1997, the F-22 has been a cornerstone of United States air superiority. Its combination of stealth, supercruise capability, and advanced avionics set new standards in air combat. The Raptor's exclusive use by the United States Air Force, due to export restrictions to protect its classified technologies, has made it a unique asset in the American arsenal. Despite its impending retirement, the F-22 continues to receive upgrades to maintain its combat effectiveness. These improvements demonstrate the aircraft's adaptability and the Air Force's commitment to maximizing its capabilities until the very end of its service life. The decision to retire the F-22 reflects the rapid pace of technological advancement in military aviation. As new threats emerge and technologies evolve, even highly advanced aircraft like the Raptor eventually reach a point where replacement becomes necessary to maintain air superiority. The F-22's retirement will mark the end of an era in military aviation history. Its legacy will live on in the lessons learned from its development, operation, and maintenance, which are already informing the design of future fighter aircraft. As the Raptor prepares to bow out, it leaves behind a remarkable record of service. Its final years will likely see it continue to play a crucial role in United States air defense and combat operations, while also serving as a bridge to the next generation of air dominance fighters. The transition from the F-22 to its successor will be a significant moment in the evolution of air warfare capabilities. Throughout its service life, the F-22 Raptor has undergone numerous upgrades to maintain its technological edge. These improvements have touched on various aspects of the aircraft, from its weapon systems to its avionics and software. One significant upgrade was the integration of new munitions families. The F-22 can now carry and deploy Joint Direct Attack munitions and small-diameter bombs, enhancing its ground attack capabilities. In air-to-air combat, the Raptor has been equipped with advanced short-range AIM-9X and medium-range AIM-120D missiles, keeping it at the forefront of aerial warfare. The F-22's radar system has also seen improvements. The installation of the enhanced APG-77V1 radar has increased the aircraft's detection and tracking capabilities, allowing it to engage threats from greater distances and with improved accuracy. Software updates have been a crucial part of the F-22's evolution. These updates have enhanced the jet's overall performance and introduced new features. For instance, the automatic ground collision avoidance system was added in 2016, significantly improving pilot safety during low-altitude operations. In 2021, the F-22 received the Multifunctional Information Distribution System Joint Tactical Radio System. This upgrade improved the Raptor's communication and data sharing capabilities, allowing for better integration with other aircraft and ground units. Some upgrades are still in development and are expected to be implemented before the F-22's retirement in 2031. These include new sensors and antennas, as well as an advanced infrared search and track system. Additionally, a tougher chromic finish is being developed to enhance the Raptor's stealth characteristics further. The Chengdu J-20, China's first operational stealth fighter, represents a significant leap in the country's aerospace capabilities. As China's answer to fifth-generation fighters like the F-22 and F-35, the J-20 showcases the nation's growing technological prowess in military aviation. One of the J-20's most distinctive features is its size. The Chinese fighter appears slightly larger than both the F-22 and F-35, giving it a commanding presence in the sky. This larger frame potentially allows for greater fuel capacity and internal weapon storage, though exact specifications remain classified. The J-20 employs a unique aerodynamic design featuring a canard delta wing configuration. This setup, with small forward wings near the nose of the aircraft, is intended to optimize airflow and enhance maneuverability. While different from the approach taken by American stealth fighters, this design choice reflects China's independent path in fighter development. Despite its unique elements, the J-20's overall shape bears some resemblance to the F-22, particularly in its fuselage design. The J-20's blended curved body exterior and twin-engine exhausts suggest possible influence from or convergent evolution with American stealth technology. The J-20's development marks China's entry into the elite club of nations capable of producing stealth fighters. This achievement underscores the country's ambition to modernize its air force, China's craft. Some upgrades are still in development and are expected to be implemented before the F-22's retirement in 2031. These include new sensors and antennas, as well as an advanced infrared search and track system. Additionally, a tougher chromic finish is being developed to further enhance the Raptor's stealth characteristics. The Chengdu J-20, China's first operational stealth fighter, represents a significant leap in the country's aerospace capabilities. As China's answer to fifth-generation fighters like the F-22 and F-35, the J-20 showcases the nation's growing technological prowess in military aviation. One of the J-20's most distinctive features is its size. The Chinese fighter appears slightly larger than both the F-22 and F-35, giving it a commanding presence in the sky. This larger frame potentially allows for greater fuel capacity and internal weapon storage, though exact specifications remain classified. The J-20 employs a unique aerodynamic design featuring a canard delta wing configuration. This setup, with small forward wings near the nose of the aircraft, is intended to optimize airflow and enhance maneuverability. While this design is different from American stealth fighters, it reflects China's independent approach to fighter development. Despite its unique elements, the J-20's overall shape bears some resemblance to the F-22, particularly in its fuselage design. The J-20's blended curved body exterior and twin-engine exhausts suggest possible influence from or convergent evolution with American stealth technology. The development of the J-20 marks China's entry into the elite group of nations capable of producing stealth fighters. This achievement underscores the country's ambition to modernize its air force and challenge U.S. air superiority in the Asia-Pacific region. While the exact capabilities of the J-20 remain speculative in the West, its existence has already altered the strategic calculus in the region. The fighter's potential to penetrate air defenses and conduct long-range strikes makes it a significant factor in any future conflict scenarios involving China. When comparing the F-22 Raptor, F-35 Lightning II, and China's J-20, we see three distinct approaches to fifth-generation fighter design, each with its own strengths and focus areas. The F-22 Raptor excels in air superiority missions, particularly with its ability to reach and maintain supercruise speed without using afterburners. This capability gives the F-22 a significant advantage in terms of speed and fuel efficiency during high-speed operations. The F-35, while also stealthy, is designed as a multi-role fighter with a strong focus on ground attack capabilities. Its advanced sensor fusion and networking abilities make it a potent information hub in modern network-centric warfare. The J-20, China's contender, appears to blend elements from both American fighters. Its larger size suggests a focus on long-range operations and potentially larger internal weapon bays. However, the J-20's exact capabilities, particularly in terms of engine performance, remain somewhat unclear to Western observers. A key area of competition is engine technology. The F-22's Pratt & Whitney F-119 engine is a benchmark in fighter jet propulsion. China has been working on its advanced WS-15 engine for the J-20. On March 2022, Chinese state media announced successful tests of the WS-15, claiming significantly improved performance, though specific details were not provided. China has reportedly built between 150 to 200 J-20s, while the United States has a fleet of 187 operational F-22 Raptors and approximately 450 F-35 Lightning IIs across various models. Each aircraft represents the pinnacle of its nation's aerospace technology and strategic priorities. As these aircraft continue to evolve, they will play crucial roles in shaping the future of aerial warfare and geopolitical power dynamics. China's plans for sixth-generation fighter development closely mirror those of the United States, showcasing the country's ambition to remain at the forefront of military aviation technology. This next leap in fighter design is expected to push the boundaries of what is currently possible in aerial warfare. A key focus of China's sixth-generation fighter program is the extensive use of artificial intelligence. Chinese specialists are working to integrate AI systems that can control various fighter systems and provide direct assistance to pilots in emergencies. This approach aims to reduce pilot workload and enhance decision-making speed in complex combat scenarios. Another critical aspect of China's plans is the development of advanced software and avionics. The goal is to create a single digital hub that integrates all air platforms, allowing for seamless communication and coordination between different aircraft and ground systems. This networked approach mirrors the concept of a combat cloud being pursued by Western air forces. China is also investing heavily in the development of swarming drone technology. These autonomous unmanned air vehicles are expected to work in conjunction with manned fighters, potentially acting as force multipliers in combat situations. Chinese aerospace companies have already begun showcasing conceptual designs for their future fighters at various air shows and in promotional videos. They have presented renderings and mock-ups of stealth, tailless fighter designs. These early glimpses suggest that China is exploring radical new airframe configurations that could offer enhanced stealth capabilities and aerodynamic performance. While specific details about China's sixth-generation fighter remain classified, the overall direction of their program indicates a focus on autonomous systems, advanced networking capabilities, and revolutionary airframe designs. As with their fifth-generation J-20, China's approach seems to blend inspiration from Western designs with their own innovative concepts, potentially leading to a unique and formidable next-generation fighter. The B-2 Spirit and the upcoming B-21 Raider represent the pinnacle of stealth bomber technology in the United States Air Force. While the B-2 has been an icon of American air power for decades, the B-21 is set to carry its legacy into the future. Stealth bombers and combat drones. The B-2 Spirit and the forthcoming B-21 Raider are pinnacles of stealth bomber technology in the U.S. Air Force. The B-2's capability to penetrate advanced air defenses while carrying a significant payload was groundbreaking. The B-21 Raider, though similar in appearance, incorporates several advancements. It will be smaller, with a wingspan reduced by 15 to 20% from the B-2's 172 feet. This reduction is expected to enhance stealth and potentially increase range. The B-21 will carry about half the payload of the B-2, around 30,000 pounds compared to the B-2's 60,000 pounds. This smaller payload helps create a thinner profile, improving stealth further. Developed with modularity in mind, the B-21 can integrate new weapons and technologies as they become available, ensuring it remains relevant for decades. The B-21 also aims to incorporate more durable and easier-to-maintain stealth coatings, learning from the B-2's operational experiences. As the B-2 nears retirement, the B-21 will continue its legacy, representing a reimagining of strategic bombing in contested airspaces. China's H-20 stealth bomber marks a significant advance in its military capabilities. Designed for long-range missions with an estimated range of 5,280 miles, the H-20's range is shorter than the B-2's over 6,900 miles. However, if China extends the H-20's range, it could threaten regions like the Philippines, Japan, the South China Sea, and Guam. The H-20 is central to China's strategy to enhance its air capabilities and global competitiveness. It represents a significant leap in China's offensive capabilities and strategic influence. In the realm of combat drones, the MQ-9 Reaper and the Chinese CH-4 stand out. The MQ-9 Reaper, developed by General Atomics, is a versatile drone with a maximum takeoff weight of 10,494 pounds. It can carry a range of weapons, including AGM-114 Hellfire missiles, GBU-12 Paveway-2 bombs, GBU-38 JDAMs, Brimstone missiles, and a 9X Block 2 air-to-air missiles, making it effective in various combat scenarios. Its high operational ceiling enhances its survivability. In contrast, the CH-4, resembling the Reaper, has a maximum takeoff weight of 2,900 pounds and a payload capacity of 760 pounds, significantly less than the Reaper. This lower capacity limits its effectiveness and makes it more vulnerable to anti-aircraft defenses. Although the CH-4 shows promise, the MQ-9 Reaper's superior payload, advanced weaponry, and combat record make it a more robust and versatile choice in modern warfare. Thank you for watching. Like this video and subscribe to our channel for more updates. And while you're still here, click the video on your screen for more mind-blowing videos.